Arrays allow you to store multiple values of the same type in one variable, a so-called array. You see an example of an array on this slide. It's a visual representation. This is an array of strings, and there are 5 arrays in it. You can see it, these are the white squares. The length of this array is 5, but just as with strings, the maximum index of this array is 4. So again, we start to count from 0. So the 0th element of this array is hello. The 4th element, so index 4, is good day. You can access elements of the array using the index. The length of an array is fixed. After creation, you cannot change the length of an array. This means that if you do want to change the length of an array, you're actually creating a whole new object instead. Arrays are characterized by the square brackets. You see these square brackets on the slide as well. It says string, so the type, and then 2 square brackets followed by the name. And then there's actually multiple ways to define an array. You can directly give it the contents, and based on these contents it can deduct the length. But it needs to know the length since it cannot be changed after creation. It needs to be known during creation time. Here you see some examples of arrays. On top we have the string array. And we create it in 2 ways. First, we create a string array with the initializers that gives it values directly. It has length 2 and the maximum index is 1. Then on the second line, we create string array 2 and we create it differently. We say new string, square brackets, and then a 2. This indicates that we want to create a string array with length 2. If you want to access any element that is more than index 1, you'll get an array index out of bounds exception. And you can do this for any type. You can use arrays on primitives and you can use it on your own custom types, like teams, as you see below here. However, you need to make sure that whatever you are adding to the array is of the specified type. If you try to add something that is of a different type, you'll get a compiler error. Let's see in IntelliJ how arrays are working. I'm going to create an int array, and I'm going to call it ints. And I have 2 ways to create this int array. I could say new int and then give it some sort of number, which would be the length. This is quite a long array. Or I can directly insert values in here. So let me do that. As you see, I have duplicate values. That's all fine. You can have duplicate values in an array. You also have negative ints. That will all work. So what this is doing, it needs to know the length upon creation of the array, and it knows the length. It just doesn't count on how many elements I've entered, and it will store all of these in the array. If I want to access an element from the array, I can use the index. As I already said, it starts to count at 0, so this one is actually 6. And I can override this value with something else if I would like that, so I'll override with 7 for now. And I can do many things with arrays. If you check the functions you have, there's quite some options. Many of them depend on the stream method first. We will not discuss this yet. It's very interesting, but it's for later. It's too difficult for now. More important, you can do a clone, which will make a copy of the array. You can get the length, which is a property of the array. It's fixed, won't be changed. If you want to have an array of a different length, you have to create a new array object. So it's actually not a lot if you leave out all these stream methods. Luckily, Java has a helper class, and it's the arrays in the java.util package. And one of the options I'm having here would be sort, for example. Sort can be used to sort the array. So if I sort int, then after that my array will be sorted. So let me prove that to you. I'm first going to print the 0th value of this array, which is 6 the first time. And then after having sorted it, it will probably be minus 89. So let me prove that. There we go. And run this. And there we go. We see that the array is sorted after having called the sort statement. There's other options, for example, binary search. I won't explain the details of this, it's quite interesting, but just know for now that if you want to search in an array for something, it has to be sorted first, or if you do it binary search way at least. If you don't sort it before doing binary search, you'll get unexpected results. Just play around with it, it's fun. So this is how you can create an array, change the elements of an array, and use this arrays helper class to perform actions on your array, such as sorting and searching. There's also multidimensional arrays. You can probably kind of guess what this is. This is an array in an array with possibly an array in an array in an array, etc. in it. So how to create those? It's actually quite straightforward. You use these square brackets twice or 3 times or etc. If you have the square brackets twice, that means that you are creating a 2-dimensional array. And these arrays, they don't need to be of the same length. So if you want to use this some sort of matrix with same length, like a square, a 4x4, you'll have to control for that yourself. Because technically, you can create every array in the array of a different length. It only needs to know the length of the first array upon creation. You see an example on the slide. It's an array that the first one has length 2. It has 2 arrays in it, which is an array of length 4, and again an array of length 4. But as I said, you don't need to do that. Let's move over to IntelliJ and have a look at these multidimensional arrays. So here we have our 1-dimensional array. If I would change this a little bit, I would add 2 square brackets to it. This is all going wrong, clearly. Well, let me show you how to change that. So we can do multiple things again. We can say new int and then just say, well, first one has length 3, second one to be determined, because it can be different for every, well, first array in the array. So if I would do this, I can go like this and say I'm going to insert an array into our first element. So that would be something like this, for example. Oh, wait, no, this is only working upon initialization. So for this one, I would actually have to create an array first, 1-dimensional, int1, for example. And then say 4, 5, 6. And then here I can say int0 equals the int1. And this is no longer allowed because this is of type int, whereas this should have been of int array. So this is one way to go about it, and I prefer the easier one for now, which would be an array in an array. So let's go for this. And I'm gonna go 1, 2, 3, 4, 5, 6. So what is the length of this array? Well, the length of this first array, so this one, is 1, 2, 3, 4. And coincidentally, it has only arrays of length 3 in it, but you cannot really specify that. So here, if I want to get a value out, for example, this one, int first, second, it's going to this array, grabbing the second index, which would be 6. So this will print 6. Let me show that. Oh, wait, I still had something funny going on down there. But this is printing 6. And this is actually going wrong for a kind of fun reason. Because it cannot sort the arrays, since it doesn't know how to order those. So this we cannot do. Let's get it out of the way. So, and you can make arrays of as many dimensions as you like.